Hey y'all, this lesson is on the basics of probability, and I think you'll see the importance of this later on in the semester when we get into hypothesis testing and probability distribution. So it'll be helpful for you as we move forward. And if you're following along in the notes, this is chapter 5. So this is what that looks like. Let's make this a little bigger. Okay. When outcomes are equally likely, so that means that they have the same chance of occurring, then probabilities can be expressed as just percentages, and this relates back to relative frequency. So whenever we talked about making a table and we counted how many times each observation occurred, and then we figured out the proportion of those were called relative frequencies, and we expressed them as decimals. So probabilities can also be expressed as decimals, and they all kind of tie in together. The probability of an event will always be in between 0 and 1, where 0 means that it could never occur and 1 means that it will definitely occur. So since the probability is a percentage, it kind of makes sense that 1 would be the highest because 1 converted to percent is 100%. So in your relative frequency table, or in a probability, if 1 is an option, then that means that it's 100%. So 1 in decimal form is 100%. What am I trying to say? In the relative frequency table, when we added up all of the relative frequencies, they should add up to 1, which converted to 100%, because if we're adding up all the observations, then they're representing all of the data, and that's 100. So an experiment is an action with an unpredictable outcome. So if we're running an experiment, we're trying to figure out what's going to happen. So just like in science, if you're running an experiment, you're doing an experiment because you're not sure what the outcome will be. And then the event is a specified desired result. So let's say my experiment is I want to know the probability of when I roll dice, and I want to know the probability that I get a 1. And so the event is, or the experiment is that I'm rolling the dice, and the event is the probability that I'm rolling a 1. And that's my desired outcome, because maybe that's my favorite number. It's not, but we'll pretend. So to find probability, you take the number of ways the event can occur, which is the frequency, and you divide it by the total number of possible outcomes, which is n in this case. So for example, when I talked about dice, there's 6 sides on a dice, anyway, 6 sides on a die, and one of those sides represents 1. So there would be a 1/6 chance that I could get a 1 in theory. So which of these probabilities would be impossible to get? 5/6, 3.5, or 0? If you chose 3.5, you were correct, because probability has to be between 0 and 1. So 3.5 is not an option. Okay. Moving on to an example. We have a standard deck of cards. If you are not familiar with cards, this is a picture of that. And we're talking about theoretical probability. So I am not actually having a deck of cards in my hands and drawing cards. That would be experimental probability, where I have a deck of cards, I'm actually drawing cards, and it's experimental, or I think it's empirical is another word. Theoretical is saying in theory. We're looking at a standard deck of cards here. I don't have the actual cards. And in theory, I'm trying to figure out the probability of each event. So in part A, I'm wanting to know the probability of drawing a 2 from a standard deck of cards. So when it's written like this, that P and then parentheses 2, that means the probability of a 2. So you go to your deck of cards and you see how many 2s are there. There's 4 2s out of the total number of cards, which in a standard deck is 52. And then you're going to want to reduce that to get 1/13. That is in fraction form, which is fine. If you wanted to figure out the decimal form, you do 1 divided by 13, and you get about 0.08, which is 8%. So there's an 8% chance of you drawing a 2 in theory. And then go ahead and try the others. Hit pause and come back. When you come back, you should have, if we're looking at hearts, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts out of 52. Go ahead and reduce. And we get 1/4, which actually makes sense if you think about it logically. The hearts represent one of the 4 different suits, I think it's called. I'm not very familiar with cards. I don't play cards a lot. And if you convert this to a percent, you should get 25%. So you have a 25% chance of drawing a heart from a standard deck of cards. And then when they say face card, it means it actually has a face on it. You might also see this as a picture card. And these cards, Jack, Queen, King, are picture or face cards. And there's 3, 6, 9, 12 out of 52. And then we'll go ahead and reduce that to get 3/13, which is about 0.23, so 23% chance of that happening. And then the last one, King of Hearts. Let's see, there's only one King of Hearts. So it'd be a 1 out of 52 chance, which is about 0.02, and that's 2%. There's a 2% chance of you drawing a King of Hearts. So that's theoretical probability. We are just in theory saying this is what we think would happen. And then if you're doing an experiment, you would actually draw the cards yourself. So here's another one. We have 2 dice are rolled. Dice is plural, die is singular. I always get those mixed up because mice is plural. No, wait. Yeah, that makes sense. Mice, plural, dice, plural. All right. I don't know why I always get those mixed up. That's kind of silly to get mixed up. 2 dice are rolled and the sum of the dice is recorded. One of my favorite ways to see the sum of dice being recorded is in a table, so I went ahead and drew the table for you. And we're finding the sum of the dice. So sum means that we're adding whatever turns up. This is in theory. We're rolling dice in theory. And these are your options for the numbers on the sides of the dice. And we're finding the sum. So if we were to roll the dice and we were to get 2 1s, that would be a 2. If we were to get a 1 and a 2, that would be a 3, 4, 5, 6, 7. So inside is the sum. So go ahead and fill out the rest of the table and come back to check it. Your table should look like this. You might have noticed some patterns as you filled out your table. On the diagonals, we have the same numbers. Across, we're going 2, 3, 4, 5, 6, 7, and then down 2, 3, 4, 5, 6, 7. 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 6, 7, 8, 9, type of thing. So if you filled it out with patterns, that's fine too. And then we're going to find the probabilities below. So you might want to pause it and try it and then come back. When you come back, you should see the sum is greater than 7. When it says greater than 7, that means bigger than 7, which actually excludes 7 because 7 is not bigger than 7. So we are not going to consider any of these in our sum. So the sum greater than 7, the number of outcomes, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them out of, whoops, 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6, 36. And then reduce to get 5/12. And in decimal form, that's about 0.42, which is 42%. Then for the others, you should find half of the outcomes are odd. And you can think about that logically, that if we have even and odd outcomes, then half of them are odd. Or if you counted them, you would get 18 out of 36. And then the sum is less than 2. There are no sums less than 2, so there's a 0% chance of that happening. And then the last one, the sum is 12. There's only one of them that represent the sum is 12 out of the 36 outcomes. And that is about a 3% chance. We were rounding. So that is it for the basics on probability. I hope you enjoyed it. If you have any questions, feel free to ask and I will be happy to help.